Hey there, so I want to show you a math problem, but it might look a little, well, a little weird at first. This is a story all about division, just maybe not in the way you're used to seeing it written down. Okay, take a look at this. Now, you can probably tell it's a long division problem, right? But the setup, it's probably not what you learned in school. What's with that vertical line and all those numbers kind of tumbling down the left side? It looks strange, but trust me, there's a really cool story happening right here. And that's really what we're going to dig into. We're not learning some brand new, crazy kind of math. Nope, we're just looking at it through a different lens. The way we write it down, the style, that's just a tool. The real goal is to get what division is actually doing. So here's the most important thing to remember. It doesn't matter if you use the little bracket we use in the States or another method you might have learned. The format is just an organizer. It's there to help you keep things straight. The real magic, the good stuff, is in understanding what every single number means and why it's there. You know, any long division format is just trying to help us keep track of the same four key players. You've got the number you're dividing by, that's your divisor. You've got the answer you're slowly building, the quotient. Then there are the chunks you're subtracting away. And finally, the most important part for our story today, what's left over each time, the remainder. All right, so let's break this thing down. We're going to walk through an example together, step by step, and I think you'll see that the process itself is something you already know really well. See, at the heart of any long division, no matter how you write it, is this simple repeating dance. First, you decide what the next number in your answer is. Then, you multiply it back. You subtract to see what you've got left, and then you bring down the next digit. And then, you just do it all over again. Decide, multiply, subtract, bring down. That's the whole game. Okay, let's get our hands dirty. Here's our problem. 1256 divided by 7. You can see the final answer there on the right, but let's pretend we don't know it. We're going to build it from scratch using this format. All right, first things first. We look at the number 1. Can 7 go into 1? Nope, too small. So we scoop up the next digit and look at 12. So the question is, how many times does 7 fit into 12? Well, just once, right? Because 2 times 7 is 14, and that's too big. So, boom, we write a 1 up top in our answer spot. That's step 1, decide. Done. Okay, now for the next two moves in our little dance. We take that one we just wrote and multiply it by our divisor, 7. So 1 times 7 is 7. Easy enough. Then we subtract that 7 from the 12 we were working with. 12 minus 7 leaves us with 5. That's our first remainder. And here is where this format starts to get really, really cool. See that remainder, the 5? We take the next digit from our main number, which is also a 5 coincidentally, and we bring it down right next to our remainder. They join forces to make our new number to work with, 55. And now we just start the cycle all over again. How many 7s can we squeeze into 55? Let's see. 7 times 7 is 49. That's pretty close. 7 times 8 is 56. Ooh, too big. So it's got to be 7. We write that 7 right next to the 1 in our answer. Okay, hit the pause button for a sec. We're right at the part where you're going to see why I think this format is so neat. It has this incredibly clear way of showing you the entire story of the calculation. Take a look at that column of numbers on the left side. See it? We had 12, then we had 55, and next up is 66. Have you spotted the pattern yet? What are these numbers actually telling us? Okay, let's connect the dots. Remember when we worked with 55? Where did that number come from? Well, look closer. The first 5 in 55, that's the remainder from our very first step from 12 minus 7. See? This format doesn't just calculate the remainder and then make you remember it. It literally brings it down and makes it part of the next step. It's right there in plain sight. And the pattern just keeps going. After we did 55 minus 49, what was our remainder? It was 6. And what's our next working number? 66. That first 6 is our remainder. It's like a chain reaction. The remainder from each step becomes the beginning of the next problem. The entire journey of these little leftover numbers is laid out right in front of you. It's so transparent. So you might be thinking, okay, that's kind of neat, but why does it matter? I mean, your phone has a calculator. You can just ask some AI and it'll spit out the answer in a split second. But here's the thing. They can give you the answer, but they can't give you the understanding. Think of it like this. A calculator just teleports you to your destination. Boom, here's the answer. But understanding the method, that's like having the map. It shows you the journey, the logical story of how place values and remainders work together to get you there. And that story, that logic, it's the same no matter what language you speak or what format you use.
And this is the real test, right? It's not about just getting the number at the end. Do you really get it? Can you explain what you're doing? Like, what chunk of the number are you working on right now? Why did you pick a 7 for the answer instead of a 6 or an 8? What does that multiplication step even represent? And what is that little remainder trying to tell you? If you can answer those kinds of questions, then you've really got it. So I'll just leave you with this question to chew on. Math isn't just a race to find an answer. It's this whole world of really beautiful, elegant ideas. And if we only ever focus on chasing that final number, what amazing concepts, what cool little stories like this visible journey of remainders are we just running right past without even noticing?